It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
There are a lot of space objects all around the universe, from stars to planets to satellites, comets, and asteroids. But our closest celestial body is the Moon, which has been subject to much research, theories, and even myths. As our only natural and permanent satellite, the Moon is in the top 10 list of biggest satellites in our solar system. It's located in an outer spiral arm of the Milky Way galaxy. Other planets in our solar system, like Mars or Jupiter, have many other moons. Saturn is the planet that tops this list, with an astonishing 82 moons, of which 53 have names. Shall I go through that list of names? No? Okay, we'll move on. Our moon, with its mean radius of 1,079 miles, isn't the biggest moon in the solar system, but is the largest compared to the size of the planet it orbits. The difference between a satellite, like the moon, and a planet isn't their size, although that might be your first thought. The largest moons in our solar system are really huge. Some of them are even bigger than planets. Jupiter actually has a bunch of these types of satellites, like the icy Ganymede. It's the largest moon in our solar system, larger than Mercury and Pluto. It may even have an underground saltwater ocean that can surpass all the water on Earth's surface. Our moon's diameter is a bit larger than a quarter of that of the Earth. When it comes to mass, though, it's 80 times less than our Earth's. To paint you a better picture, if you think about our planet as being a big hollow balloon, you would need about 50 moons to fill it. But let's look at our moon's size from a bit of a different perspective. How does it compare to the United States? Well, the US measures 2,800 miles wide horizontally, which means the moon is smaller in diameter. It's difficult for us to see it any other way, but what if our satellite was twice as big? Well, first, we would see way more of those solar eclipses. In present conditions, they can happen 2 to 5 times a year, and 5 times is more of an exception. The last time there were 5 solar eclipses in a year was back in 1935. You'll have to wait until 2206 to see the next event like this. I might be around for that. If the sun and the moon look about the same size from down here on Earth, but I guess it won't be a surprise if I tell you the star we're orbiting around is enormous. So if the sun was hollow, how many moons do you think you'd need to fill it up? Wait, no need to Google. You would need 64.3 million Earth moons, or about 1.3 million Earths. Yep, it's that huge. And while we're on the subject of our sun, it has a diameter of 864,000 miles. Its mass? Well, it's no less than 330,000 times bigger than that of the Earth. What is a star, though? I'm not a scientist here, so I'll try to keep it simple. It's a ball of bright, flaming hot matter held together by gravity. The reason why they give off both heat and light is that, well, they are very hot. Experts call the smallest stars red dwarfs because of their size and color. They're also the most frequent types of stars in our galaxy, with some of them being so tiny and dim they are invisible to people on Earth. It's the case of our nearest neighbor star, Proxima Centauri. Our sun is considered a medium star since it has an average mass, brightness, and life expectancy. There are also giant stars out there. They are rarer but easier to see. That's why you can safely assume that roughly every star you see after the sun is set is much larger than the sun. But enough about it. Let's bring it back to the star of today's show, the Moon, our only natural satellite. But is it? That may or may not be the full truth, actually. Back in 1997, a group of scientists stumbled upon an asteroid about 3 miles wide, looking like it was caught in Earth's gravitational grip. It looked like a satellite of our planet. They called it Crunia. It takes this guy about 770 years to make a trip around the Earth. It also seems that it will remain in a suspended state around our planet for at least another 5,000 years. The Moon is also kind of steering away from us. With each year, it essentially holds up some of our planet's rotational energy and uses it to launch itself about 1.5 inches higher in its own orbit. If the data we have available today is correct, back when it was born, our Moon was about 14,000 miles away from us. The distance now is 239,000 miles on average. So, what will happen when it moves away completely? Well, no more songs like Moon River, Fly Me to the Moon, How High the Moon, that's for sure. Then there will simply be no tides in our planet's oceans, and our nights would become darker. The seasons would look a lot different, and so will the lengths of our days. Based on current calculations in the science world, this will take about 50 billion years or so. So there's no need to rush out stocking up on flashlights just yet, unless you just like to hoard stuff. There's also another catch here. Our sun gets about 10% brighter every billion years. I'll spare you the calculations, but to sum up, it's more likely that long before the Earth will be left without its moon, the sun will have already swallowed them both. Gee, I don't find that any more comforting. But hey, What makes a planet, well, a planet, and why isn't our moon considered one? I mean, it's bigger than some other objects in our solar system, which are technically planets. For starters, a planet is a celestial body that does three things. It orbits around a star, not something else. It is massive enough to become roundly shaped because of its own gravity. And lastly, it has the power to snatch up any dust or fragments in its orbit as it continues to move around the Sun. So, we've established that the Moon doesn't orbit the Sun, but it doesn't really orbit the Earth either. Both of them orbit a certain point stationed between them called the barycenter. It's about 1,000 miles below the surface of Earth, sure, but still some 3,000 miles from the center of our planet. Since this barycenter lies beneath the surface of Earth, we do not consider the Moon a planet. To be able to do so, the Moon would have to be either about a third larger or a third further away, so that the barycenter would be independent of Earth's surface. The Moon does have some other planet-like characteristics, though, which makes it very special in our solar system. Firstly, it has a crust, a mantle, and a core. It also has quite an active geology, with events like our own earthquakes. You guessed it right, they're called moonquakes up there. Hey, do they have moon pies up there too? Nah, come on. Let's continue our space exploration a bit more. Wait, what? You can't hear me? Of course you can't, because space is utterly silent. Since there's no atmosphere in space, sound has no medium or way to travel for you to hear it. You will want to steer clear of Venus if you do wish to continue your outer space travels. It's the hottest planet in our solar system. It has an average surface temperature of around 840 degrees Fahrenheit. Hot! You'd think that's because it's closest to the Sun, but it's not the case. You would also think that the closest planet, Mercury, would then be the hottest. Well, since this one has no atmosphere that would help regulate the temperature, it tends to have bigger fluctuations. Your calendar would also be very messed up on Venus, since one day on its surface is about as long as a year on Earth. That's because Venus is rotating slowly around its axis, taking 243 Earth days to complete its own day. If you were to pit stop on Mars, be on the lookout for those blue sunsets. According to NASA specialists, there is some fine dust that makes the blue near the Sun's part of the sky much more visible on Mars. Any diamond fans out there? Pack your bags, because there's a planet out there made of diamonds, and it's twice the size of Earth. They believe it's mostly covered in graphite and diamond. A spacesuit costs about $12 million, but a visit there would cover the expenses altogether, don't you think? And if you're not a fan of space explorations and prefer the comfort of our planet, here's some good news for you. We have more trees right here on Earth than there are stars in our galaxy, the Milky Way. We know there are about 3 trillion trees here on planet Earth, and between 100 and 400 billion stars in our galaxy. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.